Okay, so here we have a question that's saying, all right, find the best decimal approximation of 4 times the square root of 10. And we're told also that the square roots should be approximated to the nearest 10th value. Here's how I'd start this problem. First, I deal with the square root of 8. The square root of 8 is between two numbers, two whole numbers. It's between 2 and 3. Why? Well, 2 squared is equal to 4, and we're trying to find the square root of 8. So 2 squared would be too small, it only gets you 4, and 3 squared is higher than 8, it's equal to 9. So the square root of 8 must be between 2 and 3, excuse me. So what's it closer to, 2 or 3? Well, the answer is it's closer to 3. Why? Well, because 3 squared is closer to 8 than 2 squared is. So here, right, I know I want to pick a decimal to represent the square root of 8. I'm going to pick a decimal between 2 and 3 that's closer to 3. I'll start with something like 2.8. That's closer to 3, right? 2.5 would be the halfway point. So I'm going to pick 2.8. So I just set up my multiplication. 8 times 8 is 64. Carry the 6. 8 times 2 is 16. Plus 6 is 22. Carry a place value here, because now we have a larger place value. 2 times 8 is 16. Carry the 1. 2 times 2 is 4. Plus 1 is 5. So now we get 784. It's really 7.84, right? Right, because it's a 2.8, so I just usually count the digits before the decimal, or to the right of the decimal. Since there are 2 digits here, we move our decimals to the left twice. Anyway, so 2.8 squared, we know 2 is too small. 2 squared is 4. We know 3 squared is too large, it's 9. Now we know 2.8 squared is equal to 7.84. Okay, it's still too small. So now I'm going to try something a little bit larger. I'll try 2.9. I'm not going to go any further than that. I'm not going to try 2.85 or anything, because we're only trying to approximate to the nearest tenth of a value. So tenth is 1 digit past the decimal, right? So 2.9 is the next largest place value. Okay, so 2.9 squared, or 2.9 times 2.9, what's that? Well, 9 times 9 is 81. Right, so it's 8. 9 times 2 is 18, plus 8, 26. Carry the 0, right, have a new place value. 2 times 9 is 18. 8, carry the 1. 2 times 2 is 4, plus 1 is 5. What do we get? 114, carry the 1, 7, 8. We get 8.41. So 2.9 squared is larger than 8, so it's too big. So we now pick a number between 2.8 and 2.9, except we don't have to go that far. We just need to pick which is a better approximation, 2.8 squared or 2.9 squared. Well, I would pick 2.8 squared. Why? Because 8 is what we're trying to get, and 7.84 is only 0.16 away. Whereas 2.9 squared, that gave us 8.41 minus 8, that's equal to 0.41. It's higher, it's further away. And I just switched the order here to make sure my difference is positive. You could also just take the absolute value when you subtract to find the distance between two numbers. The one that's closer is the better representation. So now what this means is I'm going to use the square root of 8, I'm going to use 2.8 as my decimal approximation. And 4 times 2.8, that's our original problem, 4 times the square root of 8, equals 8 plus what? Well, here what I do, of course, is 4 times 2 is 8. 4 times 0.8, that's just like 4 times 8, or 32, but 10 times smaller. So it's 8 plus 3.2, it's 11.2. That's my final answer. Thanks.